Hey guys, Mr. Wilson here. Today we're looking at surface area of pyramids and cones nodes. At the end of this video, you should be able to find the lateral area and surface area of a pyramid and a cone. Okay. A pyramid is a polyhedron where one of the faces, the base, can be any polygon, and the other faces, the lateral faces, are triangles that meet at a common vertex. The altitude is the perpendicular segment from the vertex to the plane of the base, and the slant height is the height of one of the lateral faces. We use the script L to represent that measure. Okay, it's going to be important for you guys to delineate or tell the difference between altitude and slant height. Okay, our altitude goes through the middle of a pyramid on the inside, and our slant height, it goes along the face of the pyramid on the outside. So the net below represents a square pyramid. See, slant height would be here. Okay, our slant height, the perpendicular height of one of the faces. All these sides are part of our bases. We're going to call each side B. Okay, we're going to draw this as a 3D rendering. Right, it would look something like this. If we were going to make a 3D rendering, it would look something like this. So, again, our altitude would be the height from the vertex to the plane in the middle. So this would be our altitude. Okay, so the difference between altitude and slant height right there. Recall that the lateral area is the area of the figure without the bases. Okay, in other words, the lateral area of a pyramid is the area of the triangles only. Okay, in this problem, there are 4 triangles. Okay, in this pyramid, we could show the lateral area by looking at the area of all of our triangles, 1/2 base times slant height. Or I said base, B times slant height, that's what we use for the side of the base, right? And then multiply that by 4, because there are 4 triangles. Okay, but if we rearrange this, we could write this as 1/2 times 4b times the slant height. Okay, and notice that 4b then represents the perimeter of the base. So we get our formula for the lateral area of a pyramid, which is lateral area equals 1/2 the perimeter of the base times the slant height. Okay, to find the surface area, we just have to include the area of the base. Therefore, the formula for to find the surface area of a pyramid is surface area equals lateral area plus base. Okay, or you might write it as 1/2 the perimeter of the base times slant height plus the base. Okay, here we're given a pyramid. It's like a square pyramid. It says the altitude is what? So as we're looking, our altitude, perpendicular distance from the vertex to the plane of the base, is 24 centimeters. Notice the altitude, slant height, and 1/2 the base form a right triangle. Okay, so here altitude, boom, 1/2 the base, right triangle, and our slant height is our hypotenuse. Okay. What is the lateral area? Okay, so to find the lateral area, remember it was 1/2 the perimeter of their base times the slant height. So we see this is a square pyramid, meaning all the sides are the same. We get one side of 20, so our perimeter should be 80. So 1/2 80 times our slant height, which is 26. Okay, and so that gives us 1,040 centimeters squared. Okay, what's our surface area? Our surface area we can find by doing our lateral area, which is 1,040, plus the area of the base. In this case, base times height, square, 20 times 20. That's 400. So our surface area is 1,440 centimeters squared. All right, number one, it says find lateral area, surface area. Let's try it out. So lateral area again, perimeter of the base. 1/2 the perimeter of the base times the slant height. Perimeter of our base here will be 24. Our slant height's 5. And so our lateral area is 60 units squared. Our surface area just adds the area of our base, right? And so our surface area is going to be 60 plus, not 2b, 60 plus 6 times 6 because it's a square base. So 60 plus 36, 96 units squared. Okay. Number two, they tell us that the base is a regular hexagon. And they want us to find the lateral area. Again, formula doesn't change even though the shape of the base changes. Okay, so for this, we'll need to have 1/2 the perimeter of our base times the slant height. Okay, and they really don't give us a whole lot to work with here. So what we do have, as we're looking at this, we know that the base is a regular hexagon, and they gave us the apothem here of the radical 3, sorry. Okay, and so as we're setting this up, our right triangle, right, our central angle should be 360 divided by 6. That goes in half here as we split to make our triangle. This is 30. This is radical 3. This would be a 30, 60, 90 triangle. So if this is radical 3, that must mean that this side is 1. Okay, right here. Okay, and our hypotenuse is 2, not that we care too much about it. Okay. All right, so as we look at it, each of these sides should be 2. And we just figured that out by looking at a 30, 60, 90 triangle there. Okay. Because our ratios are x radical 3, and 2x. Okay. And so we set that up. We found out that our perimeter then, if one side is 2, our perimeter is 12. So 1/2, 12. And now we need to know our slant height. Okay. In order to find our slant height, we have this right triangle, right? That's made. And in this right triangle, we know that this leg is 3, or radical 3. This leg is 4. And our hypotenuse is the slant height. So we'll do 4 squared plus radical 3 squared equals our slant height. 16 plus 3, sorry, slant height squared. And so our slant height squared is 19. That means our slant height is the square root of 19. Okay, so doing all that, multiply these together, we see that our lateral area should be 140. Nope, that's not right. I said 19 instead of radical 19. Radical 19. Okay, so it should be 6 radical 19. Squared. And then for our surface area, we're going to add the area of the base. So our base is a regular hexagon. Remember for that, we did 1/2 the apothem times the perimeter. And so we already know these values. Our apothem is radical 3. Our perimeter is 12. Half of that. Half of 12 is 6. So we get 6 radical 3. Oops, sorry. Now remember that 6 radical 3 is the area of our base. We already know our surface area is going to be our lateral area, which is 6 radical 19, plus the area of our base, which is 6 radical 3. Cones are treated the exact same as pyramids, except the base is a circle. And the lateral face is a sector of a circle. The formulas are almost the same. Okay, for our lateral area is going to be pi RL. Okay, and that's basically 1/2 the perimeter, which would be the circumference times the slant height. And the surface area is the lateral area, pi RL, plus the area of the base, pi R squared. L is our slant height. Okay, so here it says find the lateral area and surface area of the cone in terms of pi. So the things that we care about, 2 unknowns are our radius and our slant height. So we need to know our radius. It's 5. They told us that. 12 is our altitude. So we need to find our slant height. Again, this is going to be a right triangle. So we see 5 squared plus 12 squared should give us our slant height squared. 25 plus 144. Our slant height here is going to be 13. So now that we have those 2 values, we should be able to solve this pretty quickly. Say that our lateral area is going to be pi times our radius times our slant height, just 65 pi centimeters squared. Our surface area is going to be our lateral area plus area of our base. So we've got 65 pi plus pi R squared. Our radius is 5. 25 pi, which gives us 90 pi. Okay. And so there you have it. That is us finding the surface area of pyramids and cones. See ya.